Hello guys and welcome. I hope that you're having a good day or good morning, good evening. This is I Play 4K, aka I Play 8K, aka I Play 16K, because during this video guys today I'm going to show you Mafia II running in whopping 16K resolution, and also I'm going to show you all UHD resolution during this video benchmark. Let me real quick go ahead and show you my system. I'm having today 5300 megahertz, 5.3 whopping gigahertz, Core i9 9900K, which is overclocked from 3.6 gigahertz to 5.3 gigahertz. 6 cores, 6 threads, so 2 cores, and hyper threading technology is disabled in the BIOS. I'm using today the Asus Maximus 11 Hero Wi-Fi model motherboard, Z390 chipset. Okay, memory 32 gigabytes, the cheapest DDR4 Corsair Gen-C 2133 megahertz CL13, and today I also having two EVGA RTX 2080 Ti XC Ultra video cards that is synchronized and running in SLI and NVLink mode. So this is my single thread performance, which will be the best performance even in the CPUs that Intel is going to release in 2020. Running at stock. So this is the overclock performance, single threaded, the best, 630 points, multi-threaded performance. And let's go ahead guys and get going. Through MSI Afterburner I only overclock my VRAM to plus 700, which will give us 1400 megahertz additional on the VRAM GDDR6 memory. Let's go ahead guys and execute the Mafia II. It's a Steam version, and we're going to start with the 4K resolution, and then 5K resolution, 7K resolution, 8K resolution, 8K resolution, 16 divided by 9 aspect ratio, 10K resolution, 12K resolution, 16K, whopping 16K resolution. So here we go. Pretty much self-explanatory guys, maxed out. And let's go ahead, anti-aliasing off, and then I'm going to enable the anti-aliasing. Let's go ahead and get going guys. Benchmark. At the left top I have the system information that refresh every half second. Self-explanatory, I call it TOFFER, which showing T stands for the temperature, U stands for the utilization or usage of the component, F stands for the frequencies, FR stands for the fan rotation. In our case today we have fan rotation only 100% per each video card, which is dual fan design video cards. EVGA RTX 2080 Ti XC Ultra video cards has dual fan design, which is 100% fan rotation right now, not so noisy but noisy. And CPU is cooled with the Corsair H150i Pro water cooler system, which one of the best on the market that money can buy right now. And so it's kinda quiet, you're not gonna hear it at all, even if it's using three 120mm Corsair fans and 360mm radiator, which is one of the best. And the thermal compound I'm using today, liquid metal, and by Thermal Grizzly. Guys, the temperatures you can see in Celsius, the utilization will be in percentage. I also included the all core utilization for you just in case. Frequency in megahertz, which to get the gigahertz you gotta divide by 1000, and to get the gigahertz from megahertz. And 1950 megahertz is our maximum frequency on the EVGA RTX 2080 Ti XC Ultra video cards on the GPU frequencies running at EVGA manufacturing. But we're going to drop it down after we're going to utilize our GPU at above 90%. CPU utilization right now 63%, 55%. So that when CPU utilization reaching 99% overall, as you can see, as I included for you, this is dangerous because this is when we're getting the bottleneck. But when each core reaching 99%, it's fine. Okay, just want to let you know. What else? The GPU utilization we want to have as high as possible. So CPU utilization we want to have as low as possible, and GPU utilization we want to have as high as possible. As you can see, 114 FPS, excellent score. Let me real quick go ahead and set the anti-aliasing on, and we're going to go ahead and continue talking about the system at the information at the left top. So right now 4K, everything maxed out with the anti-aliasing is on. So guys, we want to keep CPU utilization as low as possible, that overall, the first graph as you can see. So it's if it's going to reach 99%, it's kind of bottlenecking. Otherwise it's not going to bottleneck at all, even with the 6 core. And this video is pretty much is demonstration as a fact to you that you're going to see. So 6 core is going to be more than enough even in the games 2022, guys. Here, keep that in mind. And PC gaming and console gaming will be dead in 2023, and I'm going to release a video with the facts. I'm pretty sure a lot of copycats will copy me, but I'm going to release the video with the facts why I'm going to explain to you PC gaming will be dead in 2023. So go ahead and watch it over the iPlay4k.com YouTube channel in about a month from this video. So GPU utilization and percentage as well. We want to keep GPU 1 and GPU 2 under the 2080 Ti 1 and 2080 Ti 2, which is GPU 1 and GPU 2 percentage that rate. This is GPU utilization or usage. We want to keep it as high as possible. So to get our utilization 2 times over single RTX 2080 Ti for those 2 video cards, we need to reach 97% and above, and the highest GPU utilization is better. For CPU utilization, the lowest is better. For the GPU utilization, the highest is better. So when the GPU utilization, as you can see right now, below 70%, means that we almost as equal single RTX 2080 Ti video card. When GPU utilization above 70% and 70-80%, we're about 1.8 times faster. When GPU utilization 90%, we're 1.9 times faster. When GPU utilization 97% dash 100%, we're about 1.95 times, 2 times faster than a single RTX 2080 Ti during my tests. And I'm going to include for you split screen test, but during this video we're going to just go ahead and see it the way it is. I'm recording in real time. I'm using today's ShadowPlay technology, so go ahead and add 3 FPS to the screen FPS counter to get my FPS without ShadowPlay recording in real time, because it's a software recording on the same computer. About the same results, as you can see, because with the anti-aliasing we utilize a little bit higher our GPUs, and that's why we basically utilize better our GPUs, and we receive about the same score. So pretty much 4K resolution utilization sucks. So if you're having 4K resolution screen, you want to enable to 5K resolution DSR or even higher to get better visuals and utilize your GPUs as best as you could if you're running them in SLI and if you like to play Mafia II game. So this is only applies for this game, guys. Keep that in mind. So right now we're going to go ahead and switch to 5K resolution. Let's go ahead and have a look, guys. I recorded already so many videos, so I'm losing my voice. I'm apologizing. So no anti-aliasing first, and then I'm going to enable the anti-aliasing. Okay, let's go ahead and have a look. The GPU utilization should be better now at 5K resolution. Let's go ahead and have a look by how much. As you can see already, we jumped above 70%, which is nice. So now I call it good utilization, but kind of good. But good, it's not very good. Very good will be above 80%, and excellent, I think no. Very good will be 90%, and excellent will be 97% GPU utilization for GPU 1 and GPU 2. This is how I'm calling it in SLI setup, and amazing GPU utilization will be 99-100%. Okay, 5K resolution, guys. As you can see, we're decreasing our CPU utilization, so the higher resolution will be the less CPU we'll be using. And guys, so this is the fact for you in the future PC games. We're not going to utilize that much CPU, and 6-core CPU is more than enough even in 2022 games, guys. Maximum what you can have for games is going to be 8-core CPUs, but you can have 6-core and hyper threading technology. But as again, the 6-core and hyper threading technology with total output 12 virtual core in Windows will never match 12 physical cores in Windows. Keep that in mind. And you better have more cores versus the less cores with hyper threading technology. Even the 8-core CPU with 1 core per 1 thread will outperform in games, guys, or in any heavy, not in games, but in any in games as well, in any heavy multitasking instruction versus 6-core and 12 threads or 12 virtual cores. Keep that in mind. So hyper-threading technology has a lot of delay. It's pretty much when the CPU is splitting the instructions, and it has some latency delay, and it's not worth it at all. Try to make it as I do right now. 1 core per thread is the best latency delay. 112 FPS, not bad. 45K resolution, and utilization was much better than at 4K resolution. Let's go ahead and see how much the utilization will be with anti-aliasing on. Guys, keep in mind, this is the first Mafia II video on YouTube at 16K resolution, so don't forget to smash that like button, guys. This is the unbelievable, amazing 16K resolution in Mafia II, guys. And keep in mind that Mafia II at 16K resolution is only possible with the Turing GPU architecture. With the Pascal GPU architecture or Maxwell GPU architectures, it wasn't possible at all to run 16K resolution. And 16K resolution, I'm going to show you guys in the end of this video. We are approaching slowly to it, as you can see. I tried it for Titan X Maxwell GPU architecture, and the maximum what was achievable for me was 8K resolution, and above that it was crashing. In Pascal, the maximum was achievable, I believe 10K resolution, and 12K resolution was crashing. And right now, Turing GPU architecture, maybe it wasn't the GPU architecture, maybe it was the VRAM limitation, because Titan X Maxwell GPU architecture and Titan X Pascal GPU architecture had 12 GB of VRAM, and pretty much Turing GPU architecture is compressing the data before it's storing in a frame size buffer of this 11 GB of VRAM, video RAM. So it's compressing almost 2 times higher, and it's generating 2 times less data in VRAM than Maxwell GPU architecture. Keep that in mind, the Turing GPU architecture generating 2 times less storing data in VRAM than Maxwell GPU architecture. Maybe it was the case. Maybe Mafia II at above 8K resolution used for Maxwell GPU architecture used so much of data stored in the VRAM, so it couldn't handle it. But I'm not sure it was crashing without for me to see on the screen the display. Anyways. As again, Turing GPU architecture is, yes, it is compressing. I wasn't sure before, but I just find out 2 times better compression of that data and that storing in the VRAM that Maxwell GPU architecture, and about 1.3, 1.4, 5 times versus the Pascal GPU architecture. So means that data that same resolution, same scenarios right now would use almost 2 times more VRAM than on Maxwell GPU architecture versus the Turing GPU architecture that we're having right now, because RTX 2080 Ti video cards using the Turing GPU architecture. 97.8. So as you can see, anti-aliasing is working, but our GPU utilization right now is kind of 95, 96. But in the benchmark at different angles, it wasn't that. It was even below 80% sometimes. All right. So let's go ahead, and now we're going to go ahead and do the 7K resolution, guys. I'm using this resolution a lot, and I decided to go ahead and bench it for a little bit. Okay, I have some crash here. Okay, let's do it again. The game crashed. Maybe it just don't want to take the 7K resolution. There is a possibility it just doesn't want to scale the whole game engine. Let me see again. It should take it. Okay, it took it. It just crashed it because too much higher resolution. Probably VRAM kind of overloaded and crashed for a few seconds. Alright, everything maxed out, guys. And I'm going to turn down the anti-aliasing first, and then we're going to also use the anti-aliasing. Let's go ahead and have a look. Look, keep your eye on at our GPU 1 and GPU 2 utilization. Look at this. Okay, doesn't like 7K resolution anyhow, and as you can see, the scaling is a little bit in the game is a little bit normal. Let's go ahead and use then. Okay, just doesn't like it. Not sure why, but doesn't like the 7K resolution. Alright, so we're fine. Let's go ahead and use the 8K resolution, 16 divided by 9 aspect ratio without the anti-aliasing. As you can see, here we go. And let's go ahead and bench it now. Those debris, guys, on the floor from the physics, and as you can see, the Apex company, the physics during that time wasn't owned by NVIDIA. The technology wasn't owned by NVIDIA. from the day one. It was by Apex, and Nvidia purchased the Apex, while AMD purchased the ATI. And that physics by Apex. Apex was the company that was having a great software and hardware when it comes to 3D rendering and GPU acceleration, as well as physics during the rendering in real time. So Nvidia used a lot of it technologies, as well as CUDA language from that Apex, and it's, you know, used a lot of these technologies in today's GPUs. And we having CUDA cores right now that utilizing the CUDA language, and CUDA language was the Apex company technology, not the Nvidia original. And Nvidia purchased that company. Great move by the Nvidia, by the way. Not all people will probably was old enough to remember that, but anyways, guys, look at that 8K resolution. Utilization is, I call it very good and even excellent. 78 FPS, as you can see, above 90% constantly at different angles. We're kind of limiting ourselves on GPU frequency. That's why I didn't overclock my GPUs, because when it's reaching 88 Celsius, it's pretty much thermal throttle our frequencies on GPU, and it's lowering our frequencies on GPU to keep our GPU kind of cool, so it's not going to reach above 88 Celsius. But sometimes, at some cases, we're even reaching 89 Celsius. Keep in mind that up to 100 Celsius, we're good to go, and it's safe up to 100 Celsius. Above 100 Celsius, it's going to be not safe, and you don't want to even play around 100 Celsius. You want to stay below, I would say, below 96 Celsius, 98 Celsius. Try to stay below 98 Celsius at least. But Nvidia did us a big favor, and it's keeping us below even 90 Celsius on the GPU 1 and GPU 2, so we're good to go. That's why I never overclock the GPUs. 81 FPS, great, guys. 8K resolution without the anti-aliasing. Let's go ahead and see how we're going to perform with anti-aliasing, shall we? I just want to see our VRAM, and our VRAM will be right here, this value right here, the first value, 3504 megabytes, total available 11,000 megabytes, and this is our system RAM, which is the 5917 megabytes, and total is available 32,000 megabytes. Keep that in mind. And this is our frequencies, which is 14,000 megahertz plus additional 1400 megahertz, which is 15.4 gigahertz on the GDR6, guys. Okay, anti-aliasing is on. Let's go ahead and have a look. Keep your eye on the VRAM usage as well on the CPU. Utilization probably even will be constantly 99 probably. Yep, because we're stressing our GPUs at very high right now, with so many instructions and so much data running through it, and then it's storing into frame buffer. And look, our VRAM usage is 4,000 megabytes, guys. Believe me, if this would be a Maxwell GPU architecture, it probably will be already 11,000 megabytes, or at least around 9,000 megabytes at least. But this is what I find out: Maxwell's over the Turing at least storing 2 times on Maxwell's 2 times more data in a VRAM that at the same scenes with the Turing GPU architecture. So Nvidia did a great job during the data compression in real time before it's storing into the VRAM. So pretty much 8 GB of VRAM will be good enough for any games at 4K resolution, and even sometimes at 8K resolution, 8 GB. But on the Maxwell GPU architecture, when you're running 8K resolution, at any games it was utilizing 11 GB almost at any games, including the Mafia. And at 8K resolution, it was utilizing almost 11 GB. So in Maxwell GPU architecture in the Mafia, same scene, I'm pretty sure if it would be running 8K with anti-aliasing right now, it would be over here 11,000 megabytes. Because this is what it was without the anti-aliasing. It was like 10,800 megabytes, something like that. And Maxwell GPU architecture Titan X, I'm talking about Titan X, of course, because the GTX 980 Ti didn't have that much VRAM, and so I didn't run it with the anti-aliasing on, but I remember that I did with the anti-aliasing off, and it was like 10,800 megabytes, so it was over 2 times more data stored in the VRAM with the same scenario. Keep that in mind, guys. Wow, this is impressive. I mean, this is just impressive. Alright, rank C, but in this game it's still going to be comfortable to play. So this guys was with the anti-aliasing. This is like impressive. So let's go ahead and check out 8K resolution, which is going to be for some TVs native resolution. And okay, I got the black screen again, not sure what happened. Let me cancel that. Let's do it again. Okay, so anti-aliasing is off. Let's go ahead and have a look, shall we? So we're storing 500 pixels more on width, and it's probably going to utilize, without the anti-aliasing though, it's going to utilize more VRAM that 8K 16 divided by 9 aspect ratio that we ran before. Some people that is not knowledgeable call that 8K resolution real 8K, but it's just 16 divided by 9 aspect ratio 8K. And this is another 8K which is different aspect ratio, that's all. Okay guys, below 4000 megabytes, but as again, this is without the anti-aliasing. I will real quick go ahead and try with the anti-aliasing, and we're going to see what we can achieve within the anti-aliasing. I'm just curious. But FPS is comfortable. Without the anti-aliasing, even this 8K 500 pixels more under the width resolution is incredible guys, and it's going to be comfortable, very comfortable experience. As you can see, there is no stuttering guys. Right now it's running, there is no stuttering in SLI. As again guys, I'm going to record another video, Mafia II, just a gameplay. I'm going to show you just a 16K resolution at different kind of presets and during the game. But pretty much this is the same scenario. Benchmark just showing how well it's scaling. So the reason of this video just to show you how well it's scaling. And so we can compare it with the future technologies and stuff like that, with the future GPUs and future PC technologies. Look at that scalability, almost excellent. The CPU usage is still very high. I'm pretty sure that at 16K resolution our CPU usage will be below 30%. But we're going to find out. As again, I'm recording with the ShadowPlay, so you can add at least 3 FPS every time it's updating the FPS information to get the FPS without the ShadowPlay recording in real time. And I'm not recording with external video device today, with the ShadowPlay software on the same computer. So add to this core 3 FPS guys to get the FPS. So probably going to be rank A without the recording. And now we're going to go ahead and utilize with anti-aliasing on. I gotta get going guys. ShadowPlay has some limitation while it's recording. Guys, don't forget to smash that like button guys. A lot of time, money, energy was invested, and this is the first 16K resolution of Mafia II. And by the way, I was the first YouTuber on YouTube that uploaded the first 16K resolution gameplay back in 2016 in April, May 2016. It was Half-Life 2 16K. Go ahead and Google it, Half-Life 2 16K resolution, and you will see it. I was the first. Then I was the first YouTuber that uploaded the 16K resolution Counter-Strike Go in 2018, in April 2018, because the Pascal GPU architecture and Maxwell GPU architecture couldn't handle Counter-Strike Go at 16K resolution. Keep that in mind. Maxwell GPU architecture was showing Counter-Strike Go at 10K resolution. Pascal was be able to handle Counter-Strike Go at 12K resolution with Titan XPs, and Maxwell with Titan X, of course. 10K resolution was maximum possible runnable resolution, and on Titan X, Maxwell GPU architecture, and Titan X, Pascal GPU architecture or Titan XPs was running Counter-Strike Go at 12K resolution, and the Turing GPU architecture, which is RTX 2080 Ti or Titan RTX or Titan Rex, whatever you want to call it, and SLI will be able to run Counter-Strike Go at 16K resolution guys. And Counter-Strike Go at 16K resolution on Turing GPU architecture is just a solid gameplay experience guys. It's so comfortable, there is no delay, no stuttering, it's just unbelievable smooth. And it's updated source game engine, and I believe the Counter-Strike Go it's updated its game engine in the end of 2018, so it's within the updated game engine guys. Or in 2017, I'm not sure when they updated the Counter-Strike Go, but with the newer source game engine. But I'm going to include the Counter-Strike Go video guys in the end of this video for you to study, so go ahead and check it out. It's going to be a nice video to analyze the performance. As again, the purpose of this video is not to compare the pixels. Anybody, even the donkey, knows the pixels 4K will be, you know, not worse when you're going to compare it with the 16K resolution pixels. Excellent scalability, by the way. But this is the technical video, guys, computer science video. Alright guys, 10K resolution. Anti-aliasing is off. Okay, took it nice. Let's go ahead and have a look. Now we're running extreme. Like people, oh man, upload in 16K, all those advices on the internet. You have no ability to analyze. First of all, there is no codecs in 16K resolution that can record in real time. So what's the point for me to upload a 16K resolution video when there is no such a codec that can record in 16? And even if it could, there is no such a codec, because 1 minute of 16K resolution takes about 1 minute of video to encode. Text in 16K resolution takes about 1 hour. Okay, even more than 1 hour. And there is no such a even the screenshot capture that can capture 16K resolution screenshot in real time. It will take about 3-5 seconds to capture it and store the data, because with all this color palette, the screenshot size will be about 100 megabytes, and you gotta process it and store it. So it takes some time. Okay, so there is no possibility, and this is such a stupid idea, but everybody understands there is a difference between pixels 4K and 16K or even 8K resolution. But as again, there is a compression on this video on YouTube, so what's the point to compare? Even at 4K resolution, you will see how crystal clear the pixels. But the purpose of this video, guys, is to show you the performance. So this message, guys, I delivered to the haters, because it's going to be good 29, at least 29% of them on the internet that doesn't have capability in their neuron connection to analyze the video. They even don't understand why they're watching the video. So I decided to go ahead and explain it to them. But anyways, for us, it's just to see the performance. So this is going to be the similar performance if you're going to connect it to the 16K resolution TV. Because today I'm running 8K resolution native plus DSR. Keep that in mind. That is 16K resolution and downscaling to 8K resolution. But even that, the visual is so amazing to comparing with 8K resolution native with a 16K resolution to downscale to 8K resolution. I can see the difference, guys, as well as you're going to see the difference of this video and 4K resolution, how clear it's going to be and how rich in details it's going to be. Wow, 45 FPS rank C, and you saw that 99% utilization, excellent. And look at our CPU utilization went down below 30% now. Wow, getting down, which is great. So this is the explanation, guys, for the future. You don't need more than 6-core CPU, guys, for gaming. Okay, 12K resolutions, guys, maxed out, no anti-aliasing as well. As we ran 10K resolution, no anti-aliasing but maxed out. Let's go ahead and have a look. And then I'm going to show you 16K resolution, guys, and we're going to go ahead and wrap up. As again, don't forget to hit that like button, just smash that like button, share it with your fans, because you're watching the first. Pretty much I'm going to try to record all kind of old school games at 16K resolution, so this will give us a better idea how the technology is scaling throughout the years. Well, how are we progressing? So the purpose of this video is just to see, this is the computer science video, to see the progress, to see what is capable for you to build when you're building your next PC. So you will make a smart choices during the PC builds, and you will analyze, you know, what kind of games you're playing, what kind of resolution you can handle, what kind of is maximum resolution during the GPU architecture you can handle, and such information we can compare with the future technology as well, you know, to get the perfect clear idea. Okay, hopefully everybody understands, but I'm pretty sure it's going to be some people writing those comments, you know. And for those people, I just advise them to come and ask the deity, why do you didn't left me on you know, as a water on a blanket. And just ask this question to your deity, because you know, because you're not capable to analyze, and you should ask your deity, you know, this question. Look at that, perfect GPU utilization, 99 constantly. This is perfect SLI scalability, guys, at 12K resolution. So the higher the resolution, the higher GPU utilization. And when people are saying, no, it's all about CPU bottlenecking, They do not understand that CPU bottlenecking happens only when CPU utilized by 99% or overall CPU utilization, as you can see at my first column right there, and the first value, and we're not there. And of course the higher frequency will give you the higher FPS because the higher processing of that instructions through the CPU. So you want to keep it as low cores as possible. If you're having the 6 core is good enough, and in this scenario, but the frequency as high as possible for the highest possible FPS. Plus the CPU architecture gives you about 6-10% higher performance on each newer CPU utilization. Alright guys, 16K resolution. Let's cross our fingers. Okay, took it. Excellent. Everything maxed out. Benchmark. Alright, let's see if it's going to be playable. During the gameplay, the FPS will be plus minus, as again I'm going to record the gameplay video for you, but the benchmark give us a clear idea. Wow, FPS, the source engine is much better utilization. As you can see, there's nothing that slow down this FPS. The Counter-Strike Go, same on visuals, but it's delivering over 60 FPS. It's 16K resolution maxed out, and this guy delivering below 30 FPS. But as again with physics all the way and everything all the way on. Let me go ahead and decrease the shadows, turn down the ambient occlusion, and maybe turn down the physics. This is what we're gonna do, guys. The next test, and after that I'm going to go ahead and wrap it up. So unplayable, this is not going to be playable, but as again, at least with so with a single RTX 2080 Ti we will be here about 8-9 FPS. Keep that in mind, guys. So with a single RTX 2080 Ti it's going to be just the screenshots, and I'm going to split screen for you guys. It's going to be an individual very long video when I'm going to split screen for you all 16K resolution with a single RTX 2080 Ti and 2 RTX 2080 Ti and SLI, and it will be available over the iPlay 4K, aka iPlay 8K, aka iPlay 16K, or www.iplay4k.com or www.iplayak.com YouTube channel. Nice. Pretty sure we're going to reach 30 FPS if I'm going to turn down the physics, and if I'm going to turn down some details such as ambient occlusion and make shadows, because I remember at Mafia it was a big deal. Shadows, make it from high to low. Let's go ahead and do 20 FPS, guys. Alright, keep that in mind. Okay, let's go ahead and do that, and we need to reboot the system when we turn down the, as I remember, yep, this is what we're gonna do. And let me real quick go ahead and anti-aliasing, and let me real quick go ahead and shadow quality at low and ambient occlusion at off, but everything else geometry high and texture at high, because there is no way for us to turn down that, because what's the sense? So we're still going to receive that impressive, amazing visuals, but ambient occlusion, guys, it's kind of shadows, it's kind of shading your object all the way around, kind of make it that edges better, and you're not gonna see a big difference in this game anyways. Alright, so here we go. Maxed out, guys. Can we achieve a playable classic 30 FPS experience? Let's go ahead and have a look, shall we? Yes, we can. Wow, 40 FPS. 40 FPS, guys. Here we go. I'm pretty sure if we're going to turn down the models also, quality from high to low, you're going to achieve much better FPS and probably 60 FPS playable. But as again, you don't want to do that because it's going to be nonsense. Probably play at 12K resolution with everything maxed out. But again, detailed test 16K resolution of gameplay will be available over the iPlay 4K YouTube channel. It's just going to be a gameplay. I'm going to show you that 16K resolution all the way with all kind of different presets. We're going to have some nice technical talk over there. But we're about to wrap it up, guys. Let's have a look. Excellent. 100% SLI scalability. 100% Look at that CPU utilization, below 30%. Amazing. I decided to go ahead and put for you the CPU course utilization, but you don't need that. Windows going to pretty much synchronize it, almost synchronize per core, splitting those instructions and per core, and it's going to utilize it almost equally. Delay 16K resolution, 30 FPS, which is kind of low, because there is some games that showing this delay on max GPU architecture at 8K resolution. So NVIDIA did also a great job on the latency delay between the hardware and the software, while the software, the DirectX API under the Windows 10 is managing that. I believe they cut the latency delay from maximum GPU architecture to Turing GPU architecture almost by 2 times. So the lower value is better, because after 30 milliseconds you're going to feel that stuttering, and below 30 milliseconds you're not going to feel that stuttering. But in all classic old school games such as Mafia II, 30 milliseconds still a nice delay. You're going to feel the stuttering above 40 milliseconds in Mafia 2, but in the newer games you want to keep your delay below 30 milliseconds. Alright guys, thank you so much for watching. Don't forget to smash that like button. Alright, I just did my best and I showed you today everything what is possible, and hopefully that we didn't crash the ShadowPlay video. And as again, share this video, positive comments, and check out right now I'm putting some great videos for you to check out. Check them out, rate them out guys, and support me with your likes, support me with your subscribes, support me with your shares. Thank you so much. I play 4K, iplay4k.com, and I will see you in the next videos. Peace.